Hello and welcome to Physics 232. This is the lab companion to Physics 230. I'm guessing most of you that are registered in one are registered in both. If you're only registered in one and would like to be registered in both, please contact me via email. I know one of you already has. But it's important to get things straightened out as quickly as relatively early in the semester as possible, or the summer session rather. But we're going to go over, I believe, 11 experiments over the course of the summer session. What I will do is each week I will organize lab partners for each of you. So I'll break you into groups of two. So you'll each have one lab partner. In addition to that, you will have me as your lab partner. I will be taking the data, and you will be recording the data and analyzing it. So given the circumstances, hands-on is not realistic, but I will show you how the experiments work. And I will give you enough information that you can analyze the data and draw your own conclusions from them. And hopefully gain an understanding of the physics that's going on. So I want to talk a little bit. Our first session will just be an introduction. So I'm not going to set up any experiments right this minute in this recording. But I do want to go over the syllabus for this, and also some of the basics as far as writing lab reports and the schedule. So again, if you aren't in 230, my name is Dr. Scott M. Ginelli. My email address is gianels@suny-suffolk.edu. And so you're going to be communicating with me primarily through email and also through Blackboard. And the visual demonstrations will be linked to via Blackboard, but they'll be posted on YouTube as well. I won't ask you to purchase the lab manual. I will give you PDFs of the experiments, and you can print them out if you need to. I don't think you'll need to, but you can print them out if you need to. The grade distribution will be 50% from oral presentations and lab reports, so I'll talk about what those mean. Then 25% from the lab midterm. There will be 2 exams based on material that we cover in the lab section. So the midterm will be on June 23rd, which will cover the first 5 experiments. The lab final will be on July 15th, which will cover the last 6 experiments. Consistent attendance is expected, or basically participation. There's not going to be a specific meeting time for these lab classes, but you will be asked to contribute on a weekly basis. So just to talk about what I want to do in this class, to make it interactive so that you're communicating with your peers and also with me, that in a given week, you're going to be assigned a lab partner, and that's going to be done at random, and it's going to change from week to week, so that you're not just talking to one person throughout the semester or throughout the summer session. But most weeks you will have 2 experiments. This week is an exception, and the weeks of the midterm and the final will also be exceptions. But most weeks will be, you'll have 2 lab sessions. And so what you're going to do is, once you get the data, so I will post a film on Blackboard, or post the link to a film on Blackboard. So you look at that, you will take down the data, and then you will discuss with your partner how to analyze it, and how to present it. And so for a given experiment, one of you is going to be responsible for the oral presentation, and one of you is going to be responsible for writing and submitting a lab report. Both of those will be submitted via Blackboard and will be graded via Blackboard. So you'll submit those electronically. And so if you have 2 labs in the week, then one of them, and then for the first one of you does the oral report and one of you does the lab report, and then you switch roles for the second one. So I don't want one person doing one thing each time. So one of you will be responsible for the presentation, one of you will be responsible for the lab report, but I want you to collaborate on both. You will both get the same grade for each. So if the person who presents the oral presentation, gets a 10 out of 10, the partner will get a 10 out of 10 as well. And if they get a 6 out of 10, the partner will get a 6 out of 10 as well. So it's important that you collaborate, and it works the same way for the lab report as well. One person will do it, but you'll both get credit for that. So you're going to work, the oral presentation is basically an explanation of what you did. So how did you go from the data to that I'm giving you to fulfilling the objectives of the experiment? And so if you have any questions about that as the process goes on, do not hesitate to email me. So explanations on how to make a graph in the format of a written lab report are available on Blackboard. If you've taken Physics 130 here, you've already seen this. But I'm assuming a bunch of you are from other schools. So we'll go over the structure of how to make a lab report. But I will post an explanation of how to make a graph using Microsoft Excel. You can use another spreadsheet if you would like to set up the tables and do the graphs, but do those electronically. Do not do those out by hand. It's too much of a challenge, doing things by hands under normal circumstances. But here, if everything is going to be submitted electronically anyway, you're better off doing it by computer. So I'll give instructions on how to do that in Microsoft Excel. If you want to use another spreadsheet program or another program for graphing, that's totally fine. My experience with Google Docs is that it's not ideal for graphing. It's very useful for sharing graphs among groups of people, or sharing data among groups of people. But as far as actually generating scientific graphs, it leaves a little bit to be desired. But if you're comfortable working with it and you know how to get good graphs out of that, go ahead. So I want you to submit your lab reports, ideally in PDF format. If you want to take, so you do it as a Word document, and then you submit it in PDF form. If you're not sure how to do the PDF, you can submit it as a Word document or as some other document. As long as I can read it, it's okay. So let's talk a little bit about the schedule. The schedule, we're going to start, so we have the introduction. I'm not going to really go over the electrical equipment today. I think it'll make more sense to go over them in this format when I'm doing the actual experiment. So the first experiment will be posted on Thursday, and that's Archimedes' principle, which we'll cover in the first lecture. Then electric field mapping, and then electromotive forces and basic lab measurements, then capacitors, then Ohm's law, and then we will do the lab midterm on June 23rd. After that, we'll have maximum power transfer, series and parallel circuits, RC circuits, meters, the magnetic force in a current carrying conductor, and Faraday's law of induction. The lab final and the lab midterm and the lab final will be take-home exams. I will give those, or will post those on Blackboard. You'll have 24 hours to get those back to me. And then they'll be graded and returned to you through Blackboard. The very last week, which is just a Monday and Tuesday. So on Tuesday, the 21st of July, there will be no lab activity. So it's just, so it's going to end with the lab final on July 16th. So the last thing I want to talk about here is the structure of the lab report. And so, and again, if you've taken 130 here, you already have a good idea what the format is. But I'll go over it because everybody does things a little bit differently, but here's what I want as far as the written lab report. You're going to have a title page. So the experiment, your name, the date of the experiment, and your partner. And so that your partner is very important in this format. So that's going to be one page. And everything can be done electronically. You don't need to print anything out and send me a hard copy. Just, again, you can email me the Word document or email me the PDF. If I have a preference for the PDF, but if you're not sure how to do that, the Word document is fine. So that's one page. And so the remaining sections don't have to be on their own page, but we'll start with the purpose. What is the objective of the lab? And so this could be 1 or 2 lines and, basically 1 or 2 sentences. After that, you have the introduction. The introduction consists of 2 parts. One paragraph is going to be theory. So you're going to talk about, well, what are you trying to verify? Is there a law you're trying to verify? Are there equations you're going to be working with? That sort of thing goes into the theory. The second paragraph is going to be the procedure. So what's your equipment? How does your equipment work? How do they enable you to fulfill the purpose of the experiment? So how do you, so if you're talking about Ohm's law, in paragraph 1, you're going to describe what Ohm's law is and present the equation for it. In paragraph 2, you're going to talk about how you're going to use the equipment to verify Ohm's law. And then the fourth part is the main part, and that's the data. And the data section consists of 3 things: tables, graphs, and an explanation. So you're going to organize your results into a table. If the experiment calls for you to make plots, you're going to present the plots here as well. And for each table and each graph, you should have 2 or 3 sentences explaining what that table means or what that graph means. So again, if it's Ohm's law and you're plotting voltage versus current, you should get a straight line whose slope is equal to the resistance. And you want to be able to see, okay, our data gives a good fit for the straight line, and the slope is equal to 325 ohms and gives a resistance of 325 ohms. The expected value was 330 ohms, so that's about a 2% error. So those are the kind of things that are going to be in the data section. Then you have the error analysis. So that's 2 things. You want to be able to estimate the uncertainties of your measurements and how that translates into uncertainties in your calculations. So I'll go over that a little bit. Some places are more detail-oriented where an error analysis is concerned than others, but I'll try to be, we want this to be quantitative, that you can estimate the uncertainty. And if your results agree with your expected results within the measurement uncertainties great. If they don't, you need to be able to explain why, what additional sources of error could have affected your results. And then the conclusion is a paragraph. It could be, 3 or 4 sentences, just summarizing everything that you did. And so that's the written lab report. And like I said, I also want an oral presentation. I want somebody to be able to explain, one of the two partners to be able to explain, well, how did you go about everything? So you got the data from me. How did you use that data? How did you set up the table? And, this could be just as simple as having an iPhone and showing the table on your laptop and then showing the graph and what the graph means. So you want to be able to explain that. And it doesn't have to be more than 5 or 10 minutes really. If you don't have the technology, meaning if you don't have a phone where you can video yourself, or you don't have the means of making a video recording that runs 5 to 10 minutes and that you can post on Blackboard, please let me know so we can come up with some different accommodations. So the oral presentation is basically explaining verbally what you're going to go into in a bit more detail in the lab report, but you basically want to show your results. Okay, we got the data from the video. Here's the tables we made. What do they mean? Here's the graph we made based on those tables. What do they mean? What do they tell you? And talk a little bit about the error analysis and what uncertainties you have and what % errors that you have. Do your results agree with what you expect within the uncertainties? Okay, so if you have any questions, please do not hesitate to email me. That's going to be the primary way which we'll communicate. If you want to set up a Zoom meeting, or if you want me to set up a Zoom meeting so that we can talk directly, that can also be arranged. But you'll have to email me first so I can set that up. But that's basically how we're going to work the labs in this class. So I will take the data, you're going to record the data and analyze the data and comment on the data, both verbally and written. But again, for a given week, you're going to do, for a typical week, you're going to do one oral presentation and one written lab report, and your partner is also going to do the other oral presentation and the other written lab report. So you're only going to do one of each in a given week. But we'll start with, I'll post an experiment on Thursday. And the lab reports and the oral presentations will be due the following Monday. So whether I posted on Tuesday or whether I posted on Thursday, you have until the following Monday to submit your oral presentation and your lab reports. And like I said, those are going to count for 50% of your grade. The remaining 50% is the two exams, the midterm and the final. And the midterm is going to be 5 questions. The final is going to be 6 questions, one from each experiment. And it's going to be a take-home. So I will post the exam on Blackboard. You'll have, I'll post it at 9 o'clock in the morning on the day that I've scheduled it. You will have 24 hours. So whenever you have time during those 24 hours to do the exam, that's when you're going to do it. And so that's basically it. And if you have any further questions, you can always email me. Okay, so thank you. And we will get to the first experiment in a couple of days.